I think everybody has this pamphlet, which I hope people have read cover to cover a few times. Because if you want a survival manual, this is it. If we don't get this implemented, there is no solution for any of us. Now, the thing that I had started with last week in terms of the landing of the Curiosity rover on Mars is that in a crisis like this, it is very easy to simply get terrified. Nuclear war, financial collapse, the streets are going insane, people are being shot, you know, drug-resistant forms of disease, the West Nile. I mean, the list goes on, and it's very easy to get totally terrified and bound up where you can't think about anything other than your own immediate survival. That will guarantee you and everybody you care about will not survive. That it's precisely in a crisis like that where we have to appeal to and draw out the best that is in each of us, not only to develop the solutions, but to find the courage to act on them. Because that question of courage is crucial. Nothing in history has gotten done because people sat and waited to see if it would happen. People had to define the kind of future that they wanted and decide, all right, how can I as an individual, in collaboration with other people, make that future a reality? Now, the whole point of the rover landing on Mars is that this is a beam of sunlight into this otherwise very dark situation where you can say, my gosh, we did that. What more are we capable of doing? And don't many of the problems that we seem to be facing seem rather trivial? As I mentioned last week, you know, why is there starvation on the planet Earth? We don't know how to grow food. We can't figure out that you got to have water and seed and fertilizer and some tractors, and then you can feed people. It's worked pretty well in the United States. What do we have? Maybe 3% of the population that still grows food, and we feed half the rest of the planet. So many of these problems are actually, in one sense, trivial. It simply has lacked the political will to implement the policies that would achieve that goal. And for anyone who watched the Mars, you know, rover land on the surface of Mars, and then to say, well, gee, I don't think, you know, these other problems, how to create jobs, I mean, who could possibly figure out how to do that? You know, there are no problems really here on Earth that we could find a job for someone to do, you know. So that it can change everything in terms of the mindset of people around the world, if we sort of allow it to have that effect on us and to appreciate the significance of it for all these other issues. Now, I just want to start very briefly with a short update from Mars. This is this is Sol 19. And if I were to describe something that had happened on Friday, I would have to call that Yestersol, because a day is a Earth term. The time it takes for the sun to rise and set and rise again on Mars is about 24 hours and 40 minutes. So it's not the same. The team that landed and is now directing the rover, they're coming into work about 40 hours late every day. They're on Mars time. And this, huh?
40 hours?
No, 24 hours and 40 minutes. So it's just a little bit longer, not much.
Mars is smaller than Earth.
Yes, yes.
It revolves more slowly.
No, it's much bigger. Smaller.
No, it's much smaller, Bob. Yeah, Mars is smaller.
Even though it's smaller, a day there
It's a little bit longer, but not a lot. So in terms of that, that would not require a big adjustment. But what they have managed to do, now this is actually not a very good picture, But I showed it because this is the first picture. This is the rover. This is part of the rover. This is the rim of the crater, and this is Mount Sharp. The crater is about 100 miles in diameter. This mountain is about 3 miles high in the middle, and it's maybe 6 miles from where the rover is right now. So this is the first photograph that they've taken that shows the full height of Mount Sharp, which is the sort of the ultimate destination of the rover. They're going to be doing a lot of things on the way. But so they have tested almost all of the equipment on the rover. They have a chemical laser mounted on the masthead, which can vaporize rock up to about 23 feet away, so that it can zap a nearby rock and create a spectrum from the vaporized gas that's created from this laser impulse. So they've tested that on a nearby rock, mainly just to determine that the laser, the telescope that's connected to that, the spectrometers, that all of that is working properly.
It's not done just with the laser, it's a chemical within the laser?
Well,
that
it's
the powder?
when you call it a chemical laser, that's sort of how the laser light is created.
Oh.
So I won't get into the detail of it, but it's just a description for the type of laser that it uses. But the purpose of it is to vaporize tiny amounts of rock, which then create a bright flash, which can be read by a spectrometer within the rover to read the elements that are present in that rock, so they can determine the mineral content of the rock. Okay? So they've done that successfully. They've tested out many of the other scientific equipment. Some of the sort of chemistry lab inside they have not been able to test yet, because to really test that they have to scoop up some soil and dump it inside. So they're not going to do that quite yet. The other major event was that they have moved the rover, and I'll show you. This, yeah, maybe we could. Okay, now these are the first tracks on Mars from this rover. So basically it landed here. These marks here on either side of the tracks, those are called scours, where the retro rockets from the sky crane that gently lowered the rover to the surface, where it blasted some of the dust and gravel off of the surface. So what they did was they moved the rover only maybe 10 feet. This is mainly to make sure all the motors that drive the wheels and everything work and steers properly. Then they had it spin around about 120 degrees and then back up over here. So they've driven it forward, they've driven it backward, they've turned it around. So they know it's mobile, everything is working fine. And now they're sort of, this is a fisheye lens, so it's hard to judge distance. They're sort of next to this scour, which was the one they were sort of most interested after landing, and that's one of the places where they used the chemical laser as well. They first did it on a little rock, I think it's this one over here, they called it Coronation. And then they also did it over here where the bedrock seemed to have been cleared away by the rockets. So now they have a fully functional and mobile scientific lab. The only sort of damage that's been caused on the mast, there are 2 wind sensors. And they deliberately used wind sensors which are highly sensitive but therefore more fragile. And they think that rocks that may have been kicked up by the retro rockets damaged one of them. So other than that, everything they have tested out has worked absolutely perfectly. So that's very good news. Now, what they're planning to do in the next few days is they're going to start moving to a location called Glen Elg, which from satellite photos seems to have 3 different types of terrain that meet at a single point. That's about 300 or 400 yards, maybe a quarter of a mile from where the rover landed. They're planning to drive over there and maybe take a scoop along the way, do some chemical testing when they get there. It just looks like an interesting place. And then they will begin this much longer drive to the foothills of Mount Sharp, which is really the objective of the whole mission, because of the way in which this mountain formed. It has sedimentary layers which are now exposed due to erosion over hundreds of millions or billions of years. So it should give a good geological record of the history of Mars as a whole. And I won't go into details, but this is a very interesting crater. They selected this landing site very carefully. So that's...
Is this a drawing?
No, this is a photo taken by the rover.
So where is the rover?
Well, it's a fisheye lens. So all of this stuff here is parts of the rover. There are other pictures. I think I may have shown one last week that looked more like a rover, where from the mast they were looking down and took a photo of the rover. This is a panoramic shot, and you can see it's made up of many different pictures.
Oh.
And so the object of the picture is not to show the rover, so that doesn't really...
What's that white stuff we're looking at?
This is the rover. This is the top of the rover. That's a wheel. That's part of top of the rover. That looks like the back end. This is where the nuclear power is that powers the whole rover.
How big is it?
It's about 10 feet long. The mast is about 7 feet high when it's extended. So it's sort of the size of a minivan. It weighs a ton.
This rover has multiple cameras on it?
It has 17 cameras,
Okay.
some of which are sort of hazard avoidance cameras so it doesn't run into anything. It has this laser I mentioned. It has spectrometers. It has sample collection. It has neutron devices that can shoot neutrons into the soil, in particular to try to detect the presence of water. That's going to be an important part of it. So it has a lot of different devices. The purpose is really to assess whether there are places on Mars that either are now or could have been habitable locations for the development of life. It's not going to look specifically for life. It does not have that capability. So it can analyze various organic compounds, but whether they were the product of living processes or not, it will not be able to judge. But it is the largest, most capable rover that we have ever landed on any other planet by a long shot. I mentioned the scientific payload is about 15 times greater than the Spirit and Opportunity rovers that landed in 1994.
Have you found any bacteria?
No, they have not. I mean, there were samples done back in the 1970s when we first were able to land on Mars. That was one of the immediate questions that we wanted to address: is there life on Mars? And the chemical analysis that was done at that time by most people was considered negative, although it's sort of inconclusive. And there have been other things. There was actually, there are a few chunks of Mars that have made it to Earth. They weren't brought back by astronauts, but they actually got blasted out of the surface of Mars in the distant past by asteroids. And after floating around for who knows how many years, did actually land on Earth. So there's been some microscopic analysis of some of those asteroids, which have been rather tantalizing, but at this point there's no evidence of life. That's sort of where we're moving. Now, this is going to be generating all kinds of very exciting news reports and scientific information for at least the next 2 years. That's sort of defined as the primary mission, and potentially for many, many years beyond that. Now, the question that this really brings up is, what should we do next, and what is the need for continued and expanded missions, including human missions to Mars? Why do we need to do that? And what in particular I want to get into today, we've discussed some other aspects of this last week, but the particular aspect that I want to talk about today is around what's become known as the strategic defense of Earth, and in particular dealing with asteroids. And what I want to start with is, this is sort of our classical view of the inner solar system. Now, it's not to scale at all, but you have, in fact, it doesn't even have all the planets. But you have Earth, here's Mars, there's Jupiter, and in between Mars and Jupiter, you have this asteroid belt. And our typical view of this is that that's where all the asteroids are. And that while there's a gazillion of them, they're pretty well behaved. That maybe in the distant past, you know, when you look at the moon, you look at Venus, you see incredibly cratered planets which had just been bombarded with large and small asteroids, but apparently that's pretty much stopped. That's over. So now we just have this sort of nice collection of asteroids that sort of float around. And in fact, we have been studying these asteroids, and as we speak, there is a JPL spacecraft called Dawn, which has been orbiting Vesta, which is one of the, I think it's the second largest asteroid in this main belt. And Vesta is about 300 miles in diameter. This is a picture of the south pole of Vesta. And what they did was they sent out a spacecraft which for a year now has, how many people even heard of this one? How many people even knew this was up? 2 people? Okay, 2 people. 3. For a year, it's been orbiting around Vesta. It changed its altitude so it could take close-range pictures, begin to understand their composition better, their density. And right now, it's in the process of leaving orbit around Vesta. It has I won't get into the detail, but it has a thing called an ion engine, which can continuously provide thrust, but at an extremely low level. So it can push for a year continuously, but with the force of about the weight of a sheet of paper. So it's taking several months for the Dawn spacecraft to get out of orbit around Vesta, and then it's going to go to the largest asteroid in the main belt, which is Ceres. which was discovered in 1801. And just quickly, I'll show you a picture that compares the sizes. Okay, the Earth is about 8,000 miles in diameter. Mars is about half that, about 4,000 miles. Mercury is about 2,900 miles in diameter. The Moon's 2,100 miles in diameter. Ceres is about 600. Oh, let's see. We lost Vesta down here.
Roger.
Yeah.
I calculated that Ceres has the surface area of comparable to India.
Of India. Okay. So these are the two largest asteroids in the main belt. Okay, so that's sort of a size comparison. Now, so we are studying those two asteroids in particular close up for the first time. However, the actual situation of asteroids in the solar system is much more like this. That with new telescopes, in particular, there's something called the WISE telescope, which deals with infrared radiation, is that we've determined that there is much more of a swarm of what are called near-Earth objects, which populate. That's the Sun, Mercury, Venus, Earth. So that's Earth and Mars, that populate the entire inner solar system. So it's not just this band of larger asteroids between Mars and Jupiter. And that we have only begun to really track, to try to identify and track any of these objects. So we know of some of them, but a relatively small percentage. Now, I told you that Ceres and Vesta were on the order of 600 and 300 miles. The asteroid that hit the Earth 65 million years ago, that many people believe led to the extinction of the dinosaurs, was probably about 5 miles in diameter. So much, much smaller than the asteroids that I just showed you. And I wanted to, well, never mind, I'll just show it to you. This is Meteor Crater in Arizona, which is the best preserved meteor crater on Earth. And this crater is about 1 mile in diameter, 550 feet deep, and it's believed that this hit about 50,000 years ago. Now, how big do you think the rock was that created this crater? The one that killed the dinosaurs was 5 miles in diameter. How big do you think this one was?
Yeah, probably one.
Less.
1 mile less?
It's 1 mile more wide.
That's it.
Well, yeah, the crater's only about 1 mile in diameter. So presumably the asteroid would have to be smaller.
Yeah, smaller.
How about 150 feet?
I believe it. I noticed something.
That,
It's a little
Well.
surface spot there.
yeah.
That's after the impact.
Well, the entire crater's after the impact.
Yeah, I mean when it hit.
Well, that may be more recent. I don't know about that. But now, again, no one was there that I'm aware of to take a photograph. So I can't vouch for these statistics. But what they believe, and this would partly be based on computer models and looking at craters on other planets. They believe that this asteroid was 150 feet in diameter, traveling at 26,000 miles an hour when it hit the Earth. Now, 150 feet is pretty small. That's about half the length of a football field. Okay, now, in 2007, just to make sure that you appreciate the idea that this is considered a serious threat to our planet. Okay, let's see if this. I just want to show you, this is a report to Congress from NASA on near-Earth objects, survey and deflection analysis of alternatives, March of 2007. So it was already known, many years ago that the potential for one of these near-Earth objects to actually hit the Earth was serious enough that we had to investigate it. And given the problem of trying to even see these things, which are cold, dark rocks floating in space many millions of miles from Earth, that they were basically tasked to try to find 90% of them above a certain size. So that has led to, let's see here, that has led to some things like this, where over the last, let's see, 1, 2, 5. Just since, this is 1998, just in the last, say, 15 years, the number of known, this blue curve is all near-Earth objects of any size. That's gone from maybe 1,000 to 9,000, and large ones, and I'm not sure exactly what the criteria is for that. That's gone from a few hundred to about 900. So, yeah, this is 9,000 in terms of all of them. And these are the ones that they consider large. Okay? So we've begun to identify more of this swarm of asteroids. Now, so we know most of the big ones. And just also, this is, fortunately, there aren't that many big ones, and the likelihood of a really big one hitting the Earth is very small. If you take, this is the one 65 million years ago, that might hit every 100 million years. But as you go down in size, this is the diameter of the asteroid, as you go down in size, the frequency of those hits goes up. And it's estimated that every year, something that's maybe 4 meters, 12 feet across, hits the Earth's atmosphere. People hear about shooting stars, things like that, that there are small objects that do hit the Earth or burn up in the atmosphere. So this is something that definitely does go on. And if you look at sort of further where we stand, what we do know, this is the current census of these near-Earth asteroids. These are the big ones, over 1,000 meters. Okay, something this size potentially could wipe out life on Earth. Partly because the enormous quantities of materials that get thrown up in the atmosphere. This is the way they describe what may have happened to the dinosaurs. It blocked out the sun, all the vegetation died. You could have tsunamis that wipe out you know, vast areas of coastal cities. As you go down in size, the numbers increase, as you might expect. And just to sort of all the different colored ones, after this WISE, this infrared satellite, was put on the job, the total estimated number has decreased somewhat. But as you also see, the tan ones are the ones, the percentage we've identified. And each one of these, each rock represents 100 objects. So this means we think there's about 900 objects larger than 1,000 meters in size. This would mean we think there are 2, 4, 6, 8, 10, 1,200 objects that we've identified in this size range, with a few more hundred that are probably out there. When you get down to objects that are less than 100 meters, we've found a few, but we really have no idea of how many there are. There are probably hundreds of thousands of asteroids of this size. And as I said, the one that they believe that produced the Meteor Crater in Arizona might have been about 50 meters. So that would be in this range. There could be hundreds of thousands of those objects out there.
Is there any truth to Nibiru, or is that just?
I'm sorry?
Is there any truth to Nibiru, or is that just hype, or just?
To the what?
Nibiru.
Nibiru? What's that?
Nibiru. Planet X, that's what the past between Mars and Jupiter this year. When amateur people were taking footage with their cell phones that would look like two suns in the sky over the past couple of years.
I don't know about that. There was an asteroid or a comet, Shoemaker-Levy, which hit Jupiter. People may remember that from a few years ago. We did observe a large cometary body that broke up and did impact Jupiter. Okay, now I'm going to continue a little bit of what we do know about asteroid hits on Earth. In 1908, an asteroid that may have been 50 meters exploded in the air in a remote area of eastern Siberia called Tunguska. It flattened 80 million trees over an area of 800 square miles. There was no physical meteorite remains. It exploded in air, and there were reports that it could be detected as far away as London. It took many years before they actually sent research teams in to try to assess it. That's 100 years ago. That's also in this area of under 100 meters in size, of which there could be hundreds of thousands out there. So that was only 100 years ago. So this is not something that is not going on. This is like current affairs, okay? 100 years in geological time, that's a blink. So this is a significant threat. And on top of that, September 8th of 2010, 2 asteroids passed Earth within the distance of the moon's orbit. One was maybe 50 feet in diameter, the other maybe 30 feet in diameter. And on November 8th of last year, this was in the news, an asteroid which was described as being the size of an aircraft carrier, which is this guy here. Got a nice good picture of it because it passed by so close. Size of an aircraft carrier, passed within about 200,000 miles of Earth, roughly the distance of the moon from Earth. And it is now estimated that in the year 2029, there's an asteroid, we've identified it, could pass within about 18,000 miles of the Earth. Now, if you're the geosynchronous satellites that we put up for a lot of the communication satellites that your cell phones and other global communication depend on, those are at about 22,000 miles above the Earth. So this will pass at a lower altitude than satellites that we put up around the Earth go. So that's 2029. Exactly what its trajectory is, that's one we'll be watching, okay? But far more worrisome are the hundreds of thousands that have not been identified. Their trajectories are very poorly understood. If you manage to pick out a speck in the sky, figuring out where it's going and how its current path will be affected by passing by the Earth or the Sun or the other planets or other asteroids in the meantime, is a big question, including will it bump into anything in the asteroid belt perhaps that could significantly change its path. So one of the things that you would want to do, and part of the reason for this discussion is really for the first time we have the ability to do it. Before WISE, this satellite, we couldn't even see most of these. Before we could put something, on the surface of Mars with some scientific capability, there's a real limitation about what you could do even if you did find one. So immediately you would want to have a whole array of sensors, more of these telescopes, and that we could use Mars as a vantage point from which to try to assess all of this stuff that's going on in the inner solar system, including the Earth, so that we have a second place to look at all of these things from, to get a better idea of exactly what the threat is. The other question is, and the title of that NASA study, they said deflection alternatives. That the point would be, let's say that this is the one that went by last November, but let's say that we did detect that there was an asteroid that, by best estimate, was going to hit the Earth in 20 years. What would we do? Any suggestions? Let's say we just turned on TV, an emergency news bulletin. Scientists have just discovered an asteroid that we think would wipe out life on the planet, and it will hit in 20 years.
I know.
Yeah.
Tighten NASA's budget.
Tighten NASA's budget?
Yeah.
Save money to build stronger buildings that could build a giant trampoline that it would bounce off of.
If I could save money, then I could save money so I could build myself an underground bunker.
Or yeah, we could just have a rip-roaring 20-year party and just completely give up on surviving beyond the asteroid hit.
I saw some illustrations, and I know that there are various ideas, and one of them would be to set off some type of a nuclear explosion to alter its course path.
Well, yeah, you could try to blow it up, although there's a danger that if you just have a lot of pieces and they all still hit the Earth. You could try to somehow push it, and if you could detect it and get to it while it's far enough away, so that you had, let's say you had 10 years to push it, you might be able to change its path enough that it would miss. So that's one of the ideas, is that if you could detect it early enough so you have enough time. Remember, the Curiosity mission, that started about 8 years ago, just to put a rover on Mars. So if you want to land on an asteroid with something, a bomb or a rocket or something that would move it, It would take time to develop that. So part of the idea is we need to seriously assess the dangers that are out there, and as part of a larger effort to explore and colonize space, to develop techniques that would allow you to do something. That would be the idea. Now, I'll just mention the NASA budget currently. We've talked about the cuts that have been made, that the Curiosity rover, if Obama had been elected 4 years earlier, there is no way this rover would be on Mars. It would have been canceled. The current budget has cuts 21% from planetary science in general and 38% from the Mars budget in particular. The 2012 budget was about $600 million. By 2015, it will be $200 million. So it will be cut by 2/3 between 2012 and 2015. Obama's response to any question about space is, hey, we've been to the moon, what do we need to go back for? The rover, if it hasn't found any Martians, then what's the point in that? And so in general, the approach is to eliminate much of this. There were 2 planned missions with the European Space Agency for 2016 and 2018. The US has canceled participation in both of those missions. And I'll just say this brings up the very important question of intent. And ask yourself, let me put it this way, would we have ever gone to the moon if JFK had not announced a mission to do it within the decade of the 60s?
No.
And we may have never gone. I mean, we may have put satellites in orbit and did things that help the Earth, but going to the moon, which again seems to have no immediate practical value. I mean, we brought back rocks, but they weren't gold. They're sitting in a vault someplace. What did we get out of going to the moon? And would we have ever done it if Kennedy had not seen that this was an important national goal? And remember, as I discussed last week, this occurred in the middle of the Cuban Missile Crisis. This occurred at a time of enormous strategic tension between the US and the Soviet Union. So that using this kind of a project explicitly as a war avoidance policy is extremely important. And this question of intent is everything. If Obama's going to be removed before the convention, all those people that Marnie, mentioned that have been thinking about it, saying, gee, it'd really be great if somebody else were the candidate. Wouldn't it be wonderful if somebody had the guts to stand up and say it? Well, up until now, it's been Lyndon LaRouche who has been saying it loud and clear and continuously. Is people have to be willing to act, have to be willing to put their careers, if not their lives, on the line for what must be brought about in the future. Now, in terms of this whole question of strategic defense of the Earth, asteroid defense in particular, this has become a subject of foreign relations. The Russian Deputy Prime Minister, Viktor Rogozin, last fall came out calling for joint cooperation on defense of the Earth, including asteroid defense. Now, this is a guy who, at that time, he was ambassador to NATO, who at that time as well was denouncing the policy, the commitment of the Obama administration to position anti-missile missiles in Eastern Europe. These are supposedly to defend Europe against a possible missile attack from Iran as the most likely culprit. And the Russians have said, well, you know, Eastern Europe is kind of close to us, and we would like you to put in writing that these anti-missile missiles are not being stationed in Eastern Europe to eliminate our nuclear force. And guess what? The Obama administration has repeatedly refused to even put in writing that these are not being directed against Russian missile capabilities. So the Russians have been saying, well, sorry, but this changes the strategic balance. We are not all lovey-dovey. They have been extremely alarmed by the threats by the Obama administration to simply overthrow governments at will, whether it's Syria, Libya, you know, take your pick, that they correctly view this as an imperial policy on the part of the US, and that they will defend their nuclear arsenal against these missiles if necessary. Now, the same guy, Mr. Rogozin, who is warning about that danger of nuclear confrontation with the United States, is saying there's a way that we can address this question by cooperation on science for the mutual benefit of all nations. And as I'll describe in just a minute, that this immediately echoes back to the Strategic Defense Initiative that Mr. LaRouche began pushing for in 1977 and was publicly supported by President Ronald Reagan on March 23rd of 1983. That is the way out of these sort of confrontation situations. And what happened, just very briefly, is that during the 60s, the 70s, the missile technology of both the US and the Soviet Union had reached the point where particularly sub-launched missiles could reach their target within 5 minutes. And so the amount of submarines that could be based, say, off the coast of Washington, D.C., as an example, that could not be detected, could launch their missiles and would wipe out Washington, D.C. in a matter of minutes. Meaning that the time for world leaders to assess whether this was an accident or whether it was the beginning of an all-out thermonuclear attack had disappeared, had gone to virtually zero. And that this doctrine of mutually assured destruction was becoming a hair trigger which could lead to the thermonuclear extermination of life on Earth. I mean, if one of these, you know, one of these asteroids could do it, several hundred megaton nuclear weapons could certainly do it. So that what LaRouche said at that time was, let's use new emerging technologies such as lasers with the idea that nuclear missiles could be knocked down at various points in their launch trajectory, so that accidental or whatever, we could eliminate nuclear weapons, eliminate that threat. And he proposed joint cooperation with the Soviets, and Yuri Andropov, who was president at that time, rejected it. So, but that was the idea, and that the technologies involved in that would revolutionize the economy in the process, as has the space program. So I want to conclude with a section of Ronald Reagan's speech to the country, and I'll just say this. Two of LaRouche's associates had a meeting at the Pentagon exactly 1 week before the national TV address that I'm going to show you from Ronald Reagan. They met with 9 generals and discussed this whole question of the Strategic Defense Initiative. The military leadership said, this is great, we think it's a tremendous idea, but let me tell you, this is not going to happen. And these are, you know, generals at the Pentagon. Presumably they ought to know. and they said, forget it, it's not going to happen. 7 days later, and we know the inside story of the fight that went on, literally up until the last minute he was about to get on television, about whether this section was going to be in the broadcast or not. And it was a knockdown, drag-out fight up until the last minute, and Reagan went on national television and announced this is going to be national policy. So when we tell you that that Barack Obama needs to be replaced before the Democratic Convention, and Marion tells you about all the indications are that various people would like to see that happen, and you think in your head, well, that's never going to happen. Remember this, because plenty of things, good and bad, have happened that people were absolutely convinced, for perfectly reasonable reasons, could never happen. So they do. And we have to think always from the standpoint of what is necessary and figure out how to make that happen. So I'm going to show you about 6 or 7 minutes of Reagan's speech on March 23rd of 1983. And let me get my time here. Reagan had the speech, in part he talks about plans to expand our military base in general. And then at the end of the speech he drops this bomb.
We and our allies have succeeded in preventing nuclear war for more than 3 decades. In recent months, however, my advisors, including in particular the Joint Chiefs of Staff, have underscored the necessity to break out of a future that relies solely on offensive retaliation for our security. Over the course of these discussions, I've become more and more deeply convinced that the human spirit must be capable of rising above dealing with other nations and human beings by threatening their existence. Feeling this way, I believe we must thoroughly examine every opportunity for reducing tensions and for introducing greater stability into the strategic calculus on both sides. One of the most important contributions we can make is, of course, to lower the level of all arms, and particularly nuclear arms. We're engaged right now in several negotiations with the Soviet Union to bring about a mutual reduction of weapons. I will report to you a week from tomorrow my thoughts on that score. But let me just say I'm totally committed to this course. If the Soviet Union will join with us in our effort to achieve major arms reduction, we will have succeeded in stabilizing the nuclear balance. Nevertheless, it will still be necessary to rely on the specter of retaliation, on mutual threat. And that's a sad commentary on the human condition. Wouldn't it be better to save lives than to avenge them? Are we not capable of demonstrating our peaceful intentions by applying all our abilities and our ingenuity to achieving a truly lasting stability? I think we are. Indeed, we must. After careful consultation with my advisors, including the Joint Chiefs of Staff, I believe there is a way. Let me share with you a vision of the future which offers hope. It is that we embark on a program to counter the awesome Soviet missile threat with measures that are defensive. Let us turn to the very strengths in technology that spawned our great industrial base and that have given us the quality of life we enjoy today. What if free people could live secure in the knowledge that their security did not rest upon the threat of instant U.S. retaliation to deter a Soviet attack, that we could intercept and destroy strategic ballistic missiles before they reached our own soil or that of our allies? I know this is a formidable technical task, one that may not be accomplished before the end of this century. Yet current technology has attained a level of sophistication where it's reasonable for us to begin this effort. It will take years, probably decades of effort on many fronts. There will be failures and setbacks, just as there will be successes and breakthroughs. And as we proceed, we must remain constant in preserving the nuclear deterrent and maintaining a solid capability for flexible response. But isn't it worth every investment necessary to free the world from the threat of nuclear war? We know it is. In the meantime, we will continue to pursue real reductions in nuclear arms, negotiating from a position of strength that can be ensured only by modernizing our strategic forces. At the same time, we must take steps to reduce the risk of a conventional military conflict escalating to nuclear war by improving our non-nuclear capabilities. America does possess now the technologies to attain very significant improvements in the effectiveness of our conventional non-nuclear forces. Proceeding boldly with these new technologies, we can significantly reduce any incentive that the Soviet Union may have to threaten attack against the United States or its allies. As we pursue our goal of defensive technologies, we recognize that our allies rely upon our strategic offensive power to deter attacks against them. Their vital interests and ours are inextricably linked. Their safety and ours are one, and no change in technology can or will alter that reality. We must and shall continue to honor our commitments. I clearly recognize that defensive systems have limitations and raise certain problems and ambiguities. If paired with offensive systems, they can be viewed as fostering an aggressive policy, and no one wants that. But with these considerations firmly in mind, I call upon the scientific community in our country, those who gave us nuclear weapons, to turn their great talents now to the cause of mankind and world peace, to give us the means of rendering these nuclear weapons impotent and obsolete.
I'm going to stop the speech there. If you turn on the lights. And I'll just mention that this book was published in 1983 on beam defense. The Fusion Energy Foundation, which Mr. LaRouche had formed in 1974, had become a major public advocate, I guess you would say, of not only the SDI, but of fusion energy development and the space program. And in the mid-1980s, we had 140,000 subscribers to our magazine, Fusion. So we were out there at airports, post offices, etc., recruiting people to these ideas. And it was because of that that the President of the United States decided that it was time to go with this sort of a science approach to addressing this strategic crisis. And I would just ask you, compare in your mind, here's Barack Obama. We have these conflicts, we have this crisis. Rather than trying to seize upon an opportunity like the Mars mission or the strategic defense of Earth for cooperation specifically to reduce these tensions, he is the one who is driving it consciously toward confrontation with Russia and China. And that's why we keep saying this guy must be removed. He is a threat to your personal existence. Well, this is part of it. Just quick, yeah. Yeah.
I have a question for you. Whatever makes you think removing him is going to solve the problem? Because the bottom line is this: no matter even if you remove him or not, if you put somebody else in there, then when the same thing happens, then you still got something else to complain about. Because,
well, I don't.
Hold on. But what I'm saying now, and everybody in this room knows this, with the way that this election is going on now, nobody's sticking to the issue. Nobody is.
Yeah.
Actually, and I'm saying for everybody in here, it's practically all about race. It's not really about the issue.
It's not
Because-
true.
No,
It is
hold
not
on.
true.
Hold on. The only reason why I'm saying that, is because of the fact, look, all of us have lived through a whole lot of presidential administrations when a lot of presidents do. Right? A lot of us.
Everyone has been evil since Roosevelt.
Okay, I'm saying, since Roosevelt, a whole lot of presidents did their mistakes, and they did. But what I'm saying is, even if you do get rid of Obama, it's still not going to solve the problem no matter who gets it.
Well, that's the kind of negative thinking that causes people to just sit back and complain. Look, we were out there campaigning to impeach George Bush and Dick Cheney, okay? So we are willing to go after anybody we think is a threat to the interests of this nation and the world. There is something very specific about the mentality of Obama and the people who helped to put him in, this idea of being a Nero. There is something wrong with this guy in the head. And while Mitt Romney would be every bit as bad, we are not advocating to replace one idiot with another idiot. The whole question is, can the American people define, first of all, what it is we actually need, what would actually solve the problems that we face, and then how do we implement those policies? So all the ideas, Glass-Steagall, NWAPA, all these programs are to create jobs, to build a future for all of our kids.
Right.
But none of that is going to get done with an Obama or a Romney in the White House. Now, the only pathway we can see out of that mess, and we've been saying it for a long time, is that we need a Democrat who's in the model of FDR or JFK. Okay? We've been saying for a long time, Obama never should have been president. He should have been impeached. We should remove him right now and put in another Democrat who could actually represent and stand for the policies that we need. Then we could have a president who would do something, and it wouldn't just be more of the same. So that's the challenge. I'm not saying it's easy. Maybe it won't happen. But that's the only path out of this mess that exists for us.